Okay, so let's see. Steph is in China, so teaching elementary, and just see what else comes in here. I'll just take a moment to keep an eye on this before I start. And looks like Georgina just has entered. Georgina, I'm just asking people just in the chat to put in a quick note about what you're teaching and where you're located. So I might be missing something here, but so far the only message I see here is from Steph. Oh, Miriam says from Singapore. Fantastic. And Aggie, don't teach maths, but your dad did, so you're in Shanghai, China, teach Chinese, fantastic. You know, I think tonight, even if you don't teach mathematics, I think there'll be just something of interest to you, you know, in what we're going to do here. So, so that should be good. And Miriam, I spent a lot of time in Singapore in the late 1990s and early 2000s. I developed a lot of math trails, math walks in Singapore, in Suntec City, Great World City, Botanical Gardens, along Orchard Road, the NUS Art Gallery. So I did a lot of different math walks. They're all kind of dated now. It's a long time ago, but I'm really anxious to get back to Singapore someday. So, well, look, I'll come back to the chat later on, and I'll just see what else you know, people have said here with this. But I'll begin. You know, I have something extra that I want to put in tonight with this. It involves a new children's book, and I think if you teach English or design or art or mathematics, what I'm going to put in at the end, it wasn't part of the program. You wouldn't have read about it. It's because I just came across this book recently. I came across it long after I submitted this to Ed and said, this is what I'm going to do in the webinar. So I'm going to make sure we have some time for that at the end. And I think you'll really like what you're going to see, this children's book. So I actually, I've just recently retired from the University of Toronto. So I spent 23 years as a classroom teacher. I taught middle school and elementary school, middle school and high school, elementary as well, mostly in the Toronto area. And the last 17 years, I've been at the University of Toronto, working with the next generation of teachers. So I've been teaching for over 40 years and have had a real range of levels that I've taught overall. I'm currently in a hotel room. So Texas Instruments is running a conference right now. I've been an instructor for Texas Instruments, and today was PD Day. So they flew instructors in from all over the world to get some professional development on some of the latest technology. So that's why I'm here in Fort Worth. And tomorrow, it's a conference for, you know, lots of people, not just the instructors. And I'll be doing a workshop for teachers tomorrow. So that's why I'm in this hotel room. Just get in here. I just, you know, I wanted to just thank Ed and Christine and the staff at IRCOS. I've been very lucky to have an association with IRCOS. This is a list of the things that I've been involved with IRCOS over the years, and I'm incredibly fortunate. I was actually involved before IRCOS even existed. You know, there was an organization called CETCO that I was doing some workshops, but before the pandemic, I was doing a lot of weekend workshops. If any of you want me to come out to your school, IRCOS does have some grants that are available where you could have me come out and work with your staff. Back in 2019 and 2018, I did a number of these weekend workshops, and then the pandemic came. But I will be at the Teachers Conference in Bangkok next year, and I'm just thrilled to be back at another conference, you know, there. So I'd like to begin by just talking a little bit about divisibility tests. So we may have some folks here who don't teach mathematics, but for those of you that do, just in the chat for a moment, just put something down about what a divisibility test means to you. And I'm giving you a little bit of a hint here. So, is that big number that you're looking at, is it divisible by 2? And like, how do you know without dividing by 2? So what is a divisibility test? How would you know that something is divisible by 10 or 5 or 7 or 3? Maybe down near the end, I see a couple people asking about those math walks. So how about down at the end? I'll talk about those a little bit, about what they're involved, because they're actually an idea that can be used from K to 12. So we have somebody saying yes, because it ends in an even number. So Steph says, check the ones place. So that's how we know. So these divisibility tests, they're like a shortcut so that you know whether a number is divisible by something or not without actually doing the division. Historically, these divisibility tests were really important. Today, with technology and with calculators, they're generally totally useless. However, there's still a number of good reasons for teaching them, as you're going to see tonight. So I'm going to introduce you to a young boy who discovered his own divisibility test for 7. And there's lots of stuff going on with these divisibility tests that make them still important. So you're absolutely correct. So you know if a number is divisible by 2 by just looking at the last digit. And if you see a 0, a 2, a 4, a 6, or an 8, that number is divisible by 2. You can cut it in half. And you can tell, doing that. So divisibility by 4, just look at the last 2 digits. So this big number that you see here, just look at the 18. 18, you cannot divide 18 evenly by 4. So that huge number, it's not divisible by 4. And the number 8, look at the last 3 digits. And if those last 3 digits are divisible by 8, then so is the original number. So, even though these tests are useless now, because really, you just get on a calculator and divide it, and see if it is divisible by 8. But the bigger issue is, why do these tests work? Like, why is it that you can just look at the last 3 digits for divisibility by 8? Like, why does it work? That's the more important thing today, is that issue. The divisibility by 3, if there's 1 or 2 people here who don't teach mathematics, this may be something you've never seen. It turns out you can tell if a number is divisible by 3, just add up the digits. So just go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, get the sum. If that sum is divisible by 3, then so is your original number. And when you add up the digits, you have a much smaller number. And so you can tell, that it is. So, and again, the deeper question for students is, why does this work? Because this doesn't work for 7. If you want to check if a number is divisible by 7, you don't add up the digits and check if they're divisible by 7. It doesn't work. Like, what is it about 3? Why does it work? So there's some really important questions here and notions around proof. How would you prove that it works? That test, by the way, also works for 9. So if you want to check if a number is divisible by 9, just add up the digits. In this case, it's 36. You can divide 36 by 9 evenly. And so that great big huge number is divisible by 9. So these are called divisibility tests. They're shortcuts. Historically, without a calculator, without technology, these tests were really useful. I'm not going to go into the details, but my dad was an accountant. And so by hand, he used to add up all these columns of numbers. And he used to use this divisibility test to check his work. So maybe at the end, if you want, I can go into what my father did. But there were all of these tools like this so that somebody could look at it and see if they were correct. It was amazing stuff. Today, you just do it on a calculator again if you're worried you didn't do it right. But again, it's issues of why does it work? So anyway, let's get to the divisibility by 7. So I first heard about this test for divisibility by 7 in a newsletter put out by Chris Smith. This PowerPoint file is going to be available to you in a Dropbox folder. I'll give you the link at the end. But you should sign up for Chris Smith's newsletter. So you'll have his email address in, when you go to the Dropbox folder at the end. If you want to jot it right down, you can, or if you want to take a picture of the page. Chris Smith, every week of the year, with the exception of a couple weeks, he takes a break. He puts out a newsletter, a 2-page newsletter that is filled with really cool stuff, quirky things, math stuff, jokes. It's just really cool what he does. He is not going to give your email address to somebody. He's not doing this for money. He just does it because he loves doing it. Then you will get an absolute goldmine of material from his newsletter. So this is where I read about Chika. And it was a lovely story. So he came up with his own method for divisibility by 7. And I'll show you this again in a moment. But this is the story. So his teacher, who I've corresponded with, she gave him a book. So Mary Ellis. So it was a school break. He's from Nigeria, Chika. He's in London, England, goes to a school called the Westminster School. The teacher gives him this book. And Chika notices that there's all these divisibility tests, except for 7. 7 was missing. There is one for 7, but it's really a messy, complicated, thing. So it wasn't in the book. So over this break, Chika worked out his own method, brought it to his teacher, and Mary Ellis said, never seen this before. She showed her brother, who's a mathematician in England. Her brother had never seen it before. And so they, kind of tried to find out more about this. And finally, they just felt that he'd made a discovery, that he had discovered this new method. It turns out it wasn't a discovery. The test was actually known. I've done some research on this, and it was known back in the 1940s. And there was a little bit of nasty stuff on social media. There were some people posting things saying, come on, this kid didn't discover anything. It was it's a known result. And it was really nasty because really for Chika, he discovered it on his own. It was a discovery. And it just seemed kind of a cheap shot to be, ranting against, but social media tends to do stuff like that. But they had this big celebration at his school. They really embraced what he was doing. I think there's a couple important things here. The fact that Mary Ellis recognized that Chika had some mathematical talent, that he was curious about mathematics, that she gave him this book to look at, tried to, satisfy his needs, accommodate him, and somebody who wanted to learn more. And also embracing this kid, because it would have been easy for the teachers at the school, had they known about the result, to say, that's kind of cute, Chika, but it's already known, not a big deal. End of story. That would have been really awful. So I think the way the school embraced what Chika did is really important. So I think there's kind of some sub-stories to this. Let's take a look at Chika's test. So, is the number 1055754, is that divisible by 7? So what Chika said to do is to take the last digit, it's a 4, and multiply it by 5. And then you add that to the number that's left when you take away the last digit. So you've got 1055754. Take the 4 away and add those together. And in this case, you get 105,595. And what Chika said to do was to do it again and again and again and again until you get a number that you recognize as being a multiple of 7. And if you do get a multiple of 7, then the original number is a multiple of 7. So you can see here that I've used Chika's test. I've applied it several times. When I got to 147, I could have stopped because I recognize that as being a multiple of 7. 7 goes into 147 21 times. But I decided to go one more step. And I got 49, a multiple of 7. So that means the original number is divisible by 7. You want to take a moment right now. Why don't you just pick your own number and just try the test? I mean, maybe don't pick a 50-digit number, just 750, 413, something. And just make sure that you understand, how to do the test. Because if you don't kind of get what's going on right now, the rest of the stuff we're going to do is going to be a bit of a mystery. So just make sure you understand, the steps here. So it's the last digit of the number you're testing, multiply it by 5, and add it to the number that remains when you take away that last digit. I'll just give you a moment to kind of look at this page, maybe do an example if you want. And, I don't want to just move on too quickly because, as I say, it's like the rest of what we're going to do is like, no point, if you're lost at this stage. I'll check the chat to see if there's any questions about Chika's test here. So I'm just going to keep an eye on this here. Okay. By the way, my t-shirt, this, if you don't teach math, if you don't teach high school math, the t-shirt's not going to mean anything to you. There are things called complex numbers. Square root of -4 is actually 2i. There's an I missing. Mathematically, this is not correct. But the punchline is it's all fun and games until you lose an I. So it's, it's a t-shirt that like a sports coach, might buy. Because, it's about safety and playing safely and all of that. In case you were wondering about the shirt. Okay, so I don't see anything in the chat. So here goes. Here's a second one, just to make sure you've got it. So is the number 987 divisible by 7? Take the last digit, the 7, multiply it by 5, get 35, and add it to the number that remains when you take the 7 away, 98. So 35 plus 98 is 133. I didn't recognize that as a multiple of 7. So I did it again. 3 times 5 plus 13, and I got 28. That's a multiple of 7. So the original number is also a multiple of 7. There's like a zillion questions here. Where is the 5 coming from? Like, what in the world is Chika doing here by multiplying the last number by 5? Like, where'd the 5 come from? And why is he adding it to the number that remains? And what happens if you don't get a multiple of 7? What does that mean? Does it mean that the number you started with is not a multiple of 7? So there's a lot of stuff here at the elementary and secondary level for students to think about. Good thing to have your students do is start with a number that is not a multiple of 7. Do Chika's test and see what happens. And you'll get some ideas about, what the test says, if you don't get multiples of 7. So lots of things to think about with Chika's test. One of my colleagues at the University of Toronto Teachers College Alex. I showed this to Alex, and he looked at it and he says, I've seen this before. He says, there's actually another version of Chika's test. So Chika said to multiply the last digit by 5 and add it to the other digits. My colleague said, no, don't multiply by 5, multiply by 2 and subtract it from the other digits. And Alex wrote, funny that the difference between both methods is 7. You know, one version is 5, one version is 2, 5 plus 2 is 7. Like, what's going on here? So that was fascinating that Alex knew about this. It turns out when I saw Chika's test, I'd actually forgotten that I knew about it. Back when I first started my teaching career in the late 70s, early 80s, I had come across this test in an old article in Scientific American by Martin Gardner, but I'd forgot about it. So for me, it was like a mystery. I had no idea why Chika's test was working. I mean, here's this tiny little kid was pushing me up against the wall. You know, eventually I figured it out. It actually isn't too complicated to figure it out. But, you know, so for your students, what I'd encourage you to do is have them do Chika's test, practice it a few times, try it with multiples of 7, like start with a multiple of 7, like 700 or 707. Try with numbers that are not multiples of 7, you know, play with it and try to think about how would we prove it? And can you prove it in different ways? I mean, that's a big issue today in mathematics, is learning how to, you know, prove something in different ways. This is one of my favorite songs from a long time ago called Prove It. Aretha Franklin has this raucous version of Prove It. At the high school level, when I teach trig identities and I'm proving trig identities or geometrical proofs, I always play this in class. It's kind of nice to have a song called Prove It. But anyway, that would be an important thing for you to do. The other question for your students is, are there any other tests? Like this test of Chika's is for divisibility by 7. What about 11? What about 13? What about 19? What about 23? So there's going to be a great opportunity for your students to discover, you know, a test of their own. I'll show you another one. So it turns out the answer is yes. Here is the test for 13. Take the last digit. Don't multiply it by 5. Multiply it by 4. Like what? Like where's the 4 coming from? But sure enough, if you multiply it by 4 and add it to the number that remains and do it over and over again, you know, if you get a number that you recognize as a multiple of 13, the original number is divisible by 13. So there's a test for 13. So you could show this to your students and then ask them, can you figure out a test for 17, 19, whatever, you know, prime numbers? Can you develop your own test? And by the way, Alex's version also works here. You could also multiply the last digit by 9 and subtract it from the number that's left. 9 plus 4 is 13. So there's always 2 versions, you know, of these. So this is really fascinating stuff here for students. I know that some of you may be thinking, this isn't very practical. What good is it? There was a trend up until recently where mathematics was taught in a way that, you know, we tried to find practical applications of the mathematics. But there's been a recent trend of recognizing that mathematics is a beautiful subject on its own. There's a lot of beauty and joy in this kind of mathematics. So I think what's happening now is a balance between helping students see that math is practical. It's an important subject because of how it connects to the world, but it's also a beautiful subject on its own. So I think that balance is really important. You know, so I think it's something to keep in mind if you're thinking, like, what good is this? This is about the joy and the beauty of mathematics. And what good is it? Well, it gives students a chance to make discoveries, to reason, to think about, why is this working? What's going on here? Like, those things are important too. So even though there might not be a real world application of this, it's still an important thing to see. Are there any questions so far about this? Aside from the obvious, why the heck is this working? Like Chika's test, like, where's the 5 coming from? The 13, like, where's the 4 coming from? Those are kind of obvious questions that you're probably wondering about. Is there anything else that you're wondering about? Just keep an eye in the chat here and see if, anything comes up here. I don't see anything yet. Okay. Well, I'll just cut to the chase here. It turns out that for every prime number, except for 2, there is a version of Chika's test. And it is absolutely crazy. Look at the test for 17. Take the last digit, the 7, multiply it by 12. Like, what? And add it to the number that remains. But if you look at these numbers here, this is like crazy stuff. Like, what's the pattern? For divisibility by 3, you multiply by 1. For 7, you multiply by 5. For 11, by 10. 13 by 4. 17 by 12. Like, what? It's just the pattern is really unusual here. It turns out in the Dropbox folder, I'm going to put in a collection of journal articles for you that will give all of these results. And you can do some reading, or you can pass them on to colleagues. So it may well be that this doesn't connect with what you teach. Go back to your school and tell your colleagues about this. There's got to be somebody in your school who can use this. And they can look at the journal articles. The journal articles will get into why this works. I just figured in a 1-hour kind of webinar that, I could spend half an hour going through the proof of it, but it might be more productive to do a few other things. And you and your colleagues can look over the proofs in the journal articles. But these results are just totally bizarre. Well, they seem bizarre. Once you kind of get under the fingernails of why this is working, you'll start to see what's really going on here. Like, there is a real, fairly simple reason why for 37 you multiply by 26. So anyway, you'll see more of that. I'll check the chat here. Oh, Aggie, that's such a beautiful comment. I love the approach of being balanced in the learning. Aggie, I'm really glad to hear your comment, because I have to tell you that the trend over the last number of years, it's not been particularly healthy, because there's been a number of teachers that I've worked with that when I've been doing something with them, they said, like, Ron, this is kind of nice, but like, where is this used? And when I've tried to argue a little bit about the beauty and joy of mathematics, it's been like, no. So I think the fact that in curriculums, like in Ontario where I live, right in our curriculum and in the NCTM documents, it specifically talks about the joy and beauty of mathematics and the importance of that, and not always having to have a real world connection. So it's nice that we're, teachers are getting some support to, have a balanced approach, to things. But anyway, in the Dropbox folder, you will see a whole bunch of articles, and they'll go through the reasons, all the results, and you'll see all that. This is a collection of the articles. And, for Chika, the method that he discovered, I found it in a journal article in July 1946. And, that's probably why there were a few people who were being a bit nasty, saying like, come on, I mean, this is old. Terrible the way they were reacting to this. But it turns out that these tests have been around for a long time. So you'll have all of these articles, and you'll be able to go through them at your leisure. So I don't want to belabor this, but I have something else that I want to show you with Chika's test. So just for now, completely forget about the divisibility stuff. Just forget about that totally. So here's the idea. Pick a number and just do Chika's algorithm. Let's call it an algorithm. Take the last digit, multiply it by 5, add it to the number remains, and just keep doing it over and over and over again. So we're not concerned about the divisibility now. Now it's about the patterns. So what happens if you pick a number and do Chika's algorithm again and again and again? What happens? Well, let your students explore. Maybe this demands the use of technology. It turns out if you start with 987, and if you do Chika's algorithm over and over again, there's a really weird thing that happens. You get a set of numbers that just repeats. You eventually get a 7, a 35, a 28, a 42, a 14, a 21, and that just keeps repeating. And it spins around. So you get this repeating pattern. So for your students, the question is, does this always happen? If you pick any number in the world and you do this, will you always get that cycle? We'll try it. Have your students open up an Excel spreadsheet or do some coding, use a calculator, to do this. I think this is an example of where a calculator is useful. I really value having students do things by hand, having good, strong basic skills. But that's not the point here. The point isn't to do this by hand. The point is observing the patterns. If you're going to do this totally by hand and trying to do an investigation, you're kind of spending a lot of time doing the calculations when we're trying to figure out the patterns, and see things. So personally, at this stage, I would have students using some technology, not at the start, but now. So do we always end up with that pattern? And it really demands the use of coding. So in your school, find a kid in the school who codes. There's got to be some kid in your school who codes. There's, maybe somebody on staff who codes. And write some code for this. So that you could enter in a number and then make some observations, to do that. This is a program that I wrote for a graphing calculator. I'm going to put this in the Dropbox folder if you're interested in doing this, but there's lots of other things you can do for coding. There's Scratch, there's Python, there's all kinds of stuff that you could use. Well, here's another example. I just randomly picked 22,939. Did Chika's algorithm. Multiply the last number by 5, add it to the number remains. Got the pattern again. Maybe it always happens. Well, when your students start to play with this, they're going to find, nope. There are other numbers you can start with, like 882, where you eventually get 49, and then you're stuck with 49 forever. With 49, if you take the last digit, multiply it by 5, 5 times 9 is 45, add 4, 49. So you just keep getting 49. So 882 is not the only number that does this. Good question for your students. Can you find another number that goes to 49? So can you dream up your own number that eventually reaches 49? It's actually a really nice question. Can you do it mathematically? Can you find an algebraic way, of doing that? It turns out that if your students keep trying examples, they're going to find another example where you get this huge loop. If you start with 1, 1 is not the only number that you can start with, but you get this huge loop that's 42 numbers long, and you loop around and you come right back to 1. 1, 5, 25, blah, 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 but you come right back to 1. So there's a huge loop that you come around to. And another question for your students is, what other number could you start with that would suck you into this loop and come in? How would you find it? And why is this happening? Like, why are you getting these loops? And are there any other loops that you can get? So there's 3 patterns so far. Getting sucked into that period of sex, the 7, 35, 28, blah, 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 the 49, and that huge loop. So lots of questions for your students about this, and so on. I'm going to skip over some of this because you can read through this at your leisure afterwards. It turns out those are the only 3 loops that you can get. You could pick any number in the world. And if you do Chika's algorithm, you're going to get one of these loops. Is there a way of predicting which one you're going to get? Yes, there is. And what you need to do is just find a whole bunch of numbers that go to the first loop, look at them and what do they have in common, and do the same thing for the others. And your students will start to come up with some conjectures, about that. So you can look through this. I have some information here for you, and you can do that, with that. And the business about predicting as well, you can use some programming for that. Also in the Dropbox folder, but you're going to have this PowerPoint file. I have a little bit of correspondence from you, for you that you can read from Mary Alice, the teacher. So, there's a little bit of information here. She wrote to me and told me about another student, Adam Islam. These are 2 really young boys. And Adam was just fascinated with what Chika did. So Adam put together his own website. And the website is still active. So Chika wrote to me, had some correspondence with him. And I also heard again from the teacher. She sent me the student's website. And I know you can't see it very well here, but Adam's website is unbelievable. He's got this is a young kid who's like, I think it's in grade 7 or something, but he's got this, why does Chika's test work? There's a link you can click on where you can read that. There's all kinds of stuff that this young kid has done. So I think you're just going to be amazed when you take a look at what this kid did, who was fascinated with what Chika did. So, so that information will be there for you. I'm going to just go to the end here. It's nice. I've got about 20 minutes. So I'll take a few questions in this if you have some. But this is the Dropbox folder that you can go to, where the PowerPoint file will be there. It's actually a PDF, in case you're not a PowerPoint. And all the divisibility tests are there. So it's just tinyurl.com. It's IRCOS, RL, my initials, Ron Lancaster, and the 4, because it's the 4th webinar that I've done for IRCOS. There'll be another one coming up, I think in 2 weeks. So I think it's on February 25th. That QR code will direct you to the website. But I'll just check the chat here to see if there's any questions about this. So keep an eye on it here. Okay, I don't see anything so far. Well, I'll just monitor that. Before we take a look at the children's book, which I don't mean to overstate this, but I think you're going to be amazed when you see what I'm going to show you about this book. It's like, oh my goodness. So before we take a look at the book, let me just take a moment and just tell you a little bit about the math walks. So in an effort to help my students see where math lives, see, the practical side of mathematics. Where does math live? We're surrounded by mathematics. A long time ago, in the 1990s, I was teaching in an all-girls school. And I started to take the girls into Toronto. So I was doing this mainly with my grades 7, 8, 9 girls. My calculus students came in as mentors. So I had older women mentoring the younger women. The students were in small groups. We came to Union Station in Toronto. And at that point, we did a whole bunch of mathematics in Union Station. I developed all kinds of math questions. I'll tell you what, in the Dropbox folder after tonight, I'll put in an example of a math walk, of a math trail, so that you can kind of get an idea of what one looks like. So I'll put one in for sure. But anyway, the students had a handbook with them. And so they, were in Union Station answering questions. And at that stage, what happened is everybody fanned out to different locations outside in small groups. So with small group learning, problem-based learning, project-based learning, experiential learning, all those things, wrapped up in this project. And so students went out and went to different stations. And in the earlier years, it was all my questions. And I eventually realized that I was missing an important component. So eventually I started having students develop their questions. So going to a location and looking at something and asking questions, developing it. Eventually what I started to do is I had my grade 7s develop a math walk on the campus of the school for the grade 5 students or grade 4 students. So I got the students involved in developing questions too. And it wasn't just my stuff, which I think was really an important change. But so, that's really the idea of a math trail, where students are going from one location to another, answering mathematical questions, posing math questions, working together. It's a great team building exercise. You could do one of these things early in the year. So it began in an all-girls school. Eventually, I started to develop these trails in different places. I've done them with all boys schools. I've done them in co-ed schools. It just doesn't seem to matter. It isn't, particularly for girls. I think you can do a math walk with anybody for them. So in Singapore, it turns out in the late 1990s, there was a woman in Canada named Maggie Go from Singapore. Maggie Go had a little company where she brought workshop leaders to Singapore. And she had a local contact in Singapore, Agnes Tam. And the way it worked is I would show up in Singapore and Agnes contacted local schools, and I would get 100 students a day and 10 teachers. So, and I did a lot of these in the beginning at Suntec City. So 100 students showed up by bus. 10 teachers showed up. We had a handbook for them, divided them up into groups. So there were 10 groups. And every group went around this huge mall, answering math questions. And then in the afternoon, I went and visited the school and we took up some of the questions. And then I did some other stuff with them. We did some puzzles, we did some problems. I've been involved in magic. So I did some mathematical magic tricks with them, where they analyzed the tricks. So the afternoon was kind of filled with a lot of, stuff, there. And to be honest with you, I don't know whether teachers evaluated the project or not. I mean, with my own students, I assessed the math trails using a rubric and things like that. But the teachers in Singapore, I don't know what happened. I think for some of them, it was just, it was just kind of a day where the students enjoyed doing some math in a shopping mall. I've been some places where I developed math walks, and I found that it was really important to have an assessment piece. In fact, teachers told me that because they, felt that it was important that the students knew that there was a mark associated with this. Otherwise, they might not bother doing it. I've done these trails, different parts of Asia, all throughout the United States. I have a whole bunch of them in New York City that I've developed. Math for America had me some years ago develop them in the Museum of Modern Art in the American Museum of Natural History, Ellis Island, the Bronx Zoo, campuses of NYU and Columbia. So different parts of New York, there. And I developed one in Hong Kong that I will not forget. It was at Ocean Park. And I remember the teachers telling me, they said, Ron, these kids are not like the West. They're probably not going to enjoy this. They just like to put their head down and do calculations. They just like to do their sums. So, the teachers were saying to me, don't expect much. It turns out when we got there, I had all these math questions on one side of the mountain. The rides were on the other side. There were a whole bunch of students that never got to the rides, the main attraction, because they were just so, entranced with the mathematics. So it wasn't true. They were really engaged, by, seeing kind of math in the world around us. So I think it matters where kids are from. It just, kids enjoy it. It's also a really important way of getting kids out and getting some physical exercise, as well. So, which goodness knows we need more of, If you're in a school where it would just be difficult for you to take students off campus, then do it on the campus of your school. Develop a walk, or maybe someday have me come and visit your school, and maybe a weekend workshop, and I can come and develop something on the campus of your school, and do it. But there must be things on the campus of your school that you could use. If there's just nothing in your school you could use, then you could take photographs from somewhere, maybe in your travels, or photographs of something nearby, and develop some math questions and put pictures up on your wall, in your room, or put them up in the hallway or in the gym or somewhere, and students could visit the photographs, and answer questions. It's not the same as going someplace, but, there's lots of, ways you can do this. A number of years ago, I did some consulting work at the International School in Manila. So it was in my earlier years of doing consulting work. And I'll never forget, in that school, the teachers just said to me, like, nobody is going off this campus. There was a lot of unrest at the time. Kids had protection. So we did one on the campus of the school, because there was no way we were going off campus. So a couple of you asked about the math walks. I hope that's enough to give you kind of some idea, of what they're about. And as I say, I'll put an example of a trail in the Dropbox folder for you. I still have all the ones from Singapore, from Great World City, along Orchard Park, but they're all kind of dated. So I think I'll pick out a more recent trail. I just recently did one in Madison Square Park in New York City. I might put that one in for you, or some other location for you that you can, at least see what they're about. Any questions on the math walks? Is there anything that's kind of jumping out at you? If you're wondering, how in the world would you mark a project like that? Well, I was wondering too, like, how am I going to mark this? So what I've always done over the years is I've gone to an English teacher, somebody, and I've shown them the project, and I've said, like, I'm a math guy. I don't know how to mark this. Like, give me some advice. And usually the first thing that they told me in my early years is they said, well, what did you tell the students? And I said, well, nothing. And they said, well, it's not a good idea. Students need to know how this is going to be assessed. So, I learned, I'd like to think that in my teaching career that I got better, but I think that's an area where I did get better. But it's a good thing to go talk with a colleague if you're really lost about how you would set up a rubric for marking, a project like that, and to get some help from a colleague. These math walks are a great opportunity to work with your colleagues as well. Like, why not make this a math and science walk, or a math and geography walk, or, combining different things, an integrated unit for students. It doesn't have to be just mathematics, that you're doing. By the way, if any of you are just like, you're just going crazy trying to think, well, like what kind of question could you possibly ask? Let me give you a quick example. Picture your students walking into a shoe store. There's all these boxes. They look at the boxes and they look at the shoe sizes. I'm a size 9.5, a men's 9.5. But you also see the size in Japan or in Brazil or in wherever. Like there's 5 or 6 numbers on it for the shoe size. A great math question is, what is the relationship between the shoe size in Brazil and the shoe size in North America? So if you have a whole bunch of boxes in front of you, you can collect some data. You can look at all the boxes and, make a graph. The graph of the shoe size in Brazil versus the shoe size in North America. Look at the graph. They're all linear. As the shoe size goes up, the numbers go up in any system. To be a weird system if, the shoe size went up in North America, but in Japan, the shoe size went down. They both go up. So the question is, how do they both go up? What's the relationship? That's a quick math drill question for you, which you could do in your classroom as well. You could go into a shoe store and take pictures, of boxes. But it's more interesting if you take your students into a store. Of course, you should go to the store first and talk to them and make sure that it's okay, doing this. So look, let me just close this down, this PowerPoint file, and let's take a look at this new book. So here goes. Okay. I came across this book probably about half a year ago now. It came out, I think, 2021, but I happened to be online and I noticed a review of the book in the New York Times. It was an older review from like half a year ago or a year ago or something. And wow, as soon as I got my hands on this book, I just realized that I had to use this to teach mathematics. So I have to tell you that I'm actually particularly interested in books that kind of have unusual shapes. So our rainbow book, it's a curved book. The Our World book, it actually opens up like a giant circle, and the front and back have magnets on them. And so they stick to each other and you actually form a globe with the pages. The slant book, incredible book when you're teaching parallelograms or transformations of shears. That slant book, when you open it up, it's actually 2 parallelograms side by side. I know you can see some black in that picture. That's not part of the book. It's the orange that's the book. It is not a rectangular book. And the In My Heart book has all of these hearts. As you read the book, as you flip through the book, the hearts get smaller and smaller and smaller and smaller. So it's all about dilations, shrinking. How is the area of the heart changing when you do that? So I'm particularly interested in kind of quirky, unusual books. So when I read this review in the New York Times, I just had to get a copy of this book. I know this might be hard for you to read. The name of the book is Once Upon a Time There Was, and Will Be So Much More. Each time you turn the page, the paper gets smaller and smaller until you reach the middle of the book. And it's this tiny pages. And it's like shocking. It's just beautiful. And then as you read more of the book, the pages start to get bigger. The book is about the past, the present, and the future. And the writer of this review says, it's a wonderful feat of bookmaking, but it's not just a gimmick. The changing dimensions help situate the reader in the present and enhance the book's emotional impact. It's like a lovely book. So let's take a look at some mathematics. So if you get this book, I hope that you get a few copies of it. I have no stock in Candlewick Press. I am not sharing this with you for any financial reason. I'm passionate about the book. That's why I'm sharing this with you. But if you do buy some copies of the book for your school, here's some prompts that you could use. This will be in the Dropbox folder. I'll put this in. What is it about the different size pages? Like, what's going on here? And what do you notice about the dimensions of the pages? How are they getting smaller? Measure the pages. Get out a ruler. Measure the pages. Measure the width. Measure the length. How are they changing? What's going on? And what did the author, Joanna Schauble, do? Like, how did she work all this out, to do this book? And if the publisher changed the dimensions that the author provided, how might that have changed her story? It turned out that happened. So Joanna actually had a mock-up of the book, and the publisher said, no, not using it. And because Candlewick Press likes to have all their books be the same size. So that was it. And, would a book with different size pages make it more or less expensive to print? So those are some prompts that you could use with your students. You're looking at half the book right now. So the other half looks the same. But that's what you would see if you open it up all the way to the middle. And it is this gorgeous piece of artwork. So you could have your students measure the width of the page and the lengths of the page. It turns out that they both go down linearly. It's really beautiful. So I'm not going to spend too much time in this, but if I'd done the whole workshop on this, I would have asked you what math topics could we teach with this book? What are benefits of using this book, and so on. But since it's getting close to 8 o'clock, how about I just go through and show you some of the mathematics? This is from the publisher. So this is from Candlewick Press. I reached out to them and they provided this to me. They gave me permission to share this with you. The width of the page goes down by 7 millimeters every page. The length of the page goes down by 14 millimeters. So as you keep turning these pages, 7 centimeters for the width, 14 centimeters for the length. You can have your students make their own book using whatever dimensions they want to use. Get an English teacher involved, get a design teacher involved, make their own book, write their own story, and use their own dimensions. But that's what Candlewick Press used. So there's the dimensions in a table. You could ask your students, what could you do with those dimensions rather than telling them? And you're going to get students saying, well, we could graph the length versus the width. We could graph the width versus the page number, the length versus the page number. Let's make the page number the independent variable. It's always in the x-axis. Students could calculate the area of each page, the perimeter, the aspect ratio, the width of the page divided by the length. So they could do that. The diagonal of the page, how you measure like a TV, the diagonal. By the way, the aspect ratio, the width divided by the length, is really important. You'll see that in flags, in car tires, in movies, in cinemas. Aspect ratio is a very practical thing. So let your students kind of figure out what kind of things they could do. But anyway, here's a chart. So perimeter, area, aspect ratio, diagonal. So students could calculate all of those and then make graphs. The width of the page versus the page number, the length of the page versus the page number, perimeter versus the page number. So there's all these graphs that students can make. And, this is not hard stuff. Just make a graph. What do you notice? What do you see? And then students at a higher grade level could find equations. so they could find mathematical models, for this. So this will be in the Dropbox folder for you. You'll see all of the graphs and you'll see the equations. If you don't teach mathematics, this might scare you a little bit looking at this. This is really just a linear equation. It's just y equals mx plus b. Not a complicated thing. But there's the length, formula for the length, the perimeter, formula for the perimeter, the area, multiply the width times the length. So there's a whole bunch of stuff here. If anybody here teaches high school, the length of the diagonal is an interesting function, and so is the aspect ratio. It's a rational function. So I'll leave it to you to look through this, take a look at this, maybe share it with a colleague. Maybe this isn't what you teach, but get somebody else at the school to use this. The final thing I want to tell you is a couple of things. One of them is that coding could be important here. Doing some coding so that you could make the artwork, with some coding using those equations. But I want to tell you a little bit about Joanna Schauble. So when I reached out to her, I wanted to know what she did to make the book. So what was her thinking? So we exchanged some email messages. I Zoomed with her about 3 weeks ago. We finally got a chance to chat. She just emailed me tonight. She said, I'm doing a workshop in 2 days for teachers in Sweden. I want to show them your math file. So I emailed her this file. So she's going to do a little workshop for these teachers and incorporate some math into it. But when she wrote to me, the first thing she said was like, OMG, like a math teacher using the book? No way. She couldn't imagine a math teacher using the book. But then she said to me, I'm really bad at mathematics. This is heartbreaking. This is a condemnation of the way she was taught. And let's be honest, some students are still taught this way, where we don't value, their thinking. Because, well, you know what? You be the judge. I'm going to show you some of her mathematical thinking that I think is really beautiful. I think she is good at mathematics. What do you think? Here's from her notes. So what do you think? Is this somebody who's bad at mathematics? Look at the detail. Look at the organization, the experimentation, trying different numbers. Like, how could she possibly say that she's bad at mathematics? Her diagrams, her models, the physical models. The idea of thinking of using the physical model and making one and experimenting with different sizes. By the way, one of the things Joanne told me that blew her away is when she made these models, the first page of the book, the aspect ratio was less than 1. The width was smaller than the length. But as she got into the middle of the book, now the width was bigger than the length. The aspect ratio went above 1. Like, she was noticing all this stuff. She was thinking about this. Like, I don't know, maybe you disagree with me, but I just don't think this is somebody who's bad at mathematics. And it's like terrible that she felt that way. But anyway, I think that's, maybe a good thing for all of us to reflect on is, what we value, the kind of mathematical thinking that we see in students and the kind of mathematics we value, as well, in our classes. Anyway, Joanna does workshops for teachers and students. Maybe you might want to invite her to your school someday and have her come and work with your kids. And she has students make books. She has them write books. And but for you, maybe you could put together some kind of project for your teachers where you integrate some arts and design and creative writing and mathematics, having students write a story, and then putting books up, the books that your students make, and putting them on display. The other thing you might want to do is think out of the box. You saw Joanna's book, The Rectangular Pages. What else could you do? Just challenge your students. For me, I've been thinking about a book like this that uses circles, where you go through the book and read it, and the circles get smaller and smaller and smaller going through it. So, it's an interesting question to think about what that would look like. By the way, when I talked to Joanna, I showed her this. And, I said to her, I said, wow, this book would be very expensive to make. And she said, stop. She said, you don't think that way. She said, if I would have thought about the cost of the book, I never would have pursued the project. I would have given up before I even started. She said, it's the worst thing to defeat yourself before you start. And I think that's also a good message for students. She said, the last thing you should think of is the cost. If it's expensive and it doesn't get made, well, you tried. I mean, maybe you can use your ideas somewhere else, but at least you tried. You've got something that you could use maybe somewhere else. So I thought it was a wonderful comment, that she had made. That's a picture of what the book looks like when you're in the middle. It's like this gorgeous work of art. And the story is really beautiful. So I'll pop that into the Dropbox folder. I don't have it in there right now, but when we start in a minute, when we stop in a minute, I will put it in. And I'm just taking a look at any of the final comments here. I'm happy to stay on if there's some questions. But Aggie says, the comment from before, but Aggie also says, thank you very much for seeing maths in people and elsewhere. And also, believing in people. It's an important thing, to do that. We can easily turn students off the subject, by not valuing their thinking. Kids who are coming from different cultures, who have different ways of doing things. I think it's kind of old school. I mean, I went through a school system where there was kind of a way of doing it. I was always the kid in class who was saying to my teacher, I got another way of doing this problem. And most of the time I was shut down. It was like, Ron, just do it this way. And, for new teachers, I mean, I've been working with new teachers for the past 17 years. It's really hard for a new teacher because you got some kid in your class who's got this like crazy way of doing the problem. And, you're looking at it thinking, I don't know what this is. It's like really tempting just to dismiss it, and say, look, just do it this way. I think it's important for us to stop and actually, maybe not on the spur of the moment, but to stop and look at what they're doing, because there could be a lot of value. Anyway.
Ron,
yeah.
If there aren't any other questions, let me just interrupt you briefly to say thank you. This has been so much more than advertised. Really a lot to think about. Would love to make a connection with Joanna at some time as well. For maybe she'd like to come to one of our conferences and run a workshop. I mean, this is phenomenal.
Ed, you've got me coming to the 2024.
You're right.
Let's see if we can
Let's give it a think. But are there any questions before? I want to turn off the recording unless there are questions that. Okay, well then let me just say thank you to everybody, and you can stay on, but I'm going to turn off the recording.
Yeah, I'll stay on for a few minutes and see what happens, Ed.
But thank you for your time today, everybody.
Yeah, and thank you for all of you giving up a Saturday morning for you to come and do this. I'm so happy that you've done this. And let me know if I can be of any help. You've got my email address and the handouts inside the Dropbox folder, and happy to connect with you.